All right, so let's do some page 2. Properties of sound waves. Okay, so I can tell you guys the easiest way to do 1 through 5 is to straight up Google type in wave, picture of wave, or labeled picture of wave. Click images after you Google it, bam, everything's going to be easy. But let's go through it anyways. So, number 1, how fast a wave moves through median. Well, that's kind of a given, right? So that's just straight up speed. Easy. How long the wave is. Well, long, length, that one's pretty much a piece of cake too. That's wavelength. How often? Okay, how often a particle vibrates generally is it's frequency, right? It's like how often do you go to this store? How much people would say, well, how often do you frequent the store? You know, frequency. So that's how many times it goes up and down. Does it go up and down this much, or does it go up and down this much? A lot less, right? How much time it takes for a particle to complete a vibrational cycle. This is the giveaway from this one. To complete a cycle. So how much time in a period, a certain period of time. So that's actually a period, right? So that one's easy. So that one, bam. And number 5, how far the particles vibrate away from their resting position. So remember, their resting position is this flat line. So how far they go? So this far, this far, this far, this far. See how far they go from that middle flat line is what this one is. So that's its amplitude, right? Higher amplitude would be something like this. Lower amplitude might be like this one. Okay, but again, if you Google a wave or whatever, search up a wave, easy. Okay, let's go to number 7. The pitch of a sound is directly related to the blank of a sound wave. Okay, so first off, direct relationship means when you increase one, you increase the other. When you decrease one, you decrease the other. So let's think about this. If you're trying to make a high-pitched sound, you have to put a lot of energy into that. And you can do it right now, or like when you're by yourself. When you're trying to make a low-pitched sound, it's very low energy. So think about vibrations, very low. Boo, right? That's low. High pitch, a lot of high energy, right? And I'm going to play a video. We're going to skip through it, and you guys can search this up yourself. Search up a sound test on YouTube. So let's check it out. You're not going to be able to hear it at first. See, not even when I turn up, you can't hear it. So notice, low frequency, you can't even detect the pitch yet. Let's skip ahead. So we're at 90 hertz. Okay, there. You hear that? So notice, just even straight up looking at the length of time we play in it, low frequency, which is how often it goes up and down, low sound. If we skip ahead, first off, look at the frequency. It's very high because there's a lot of them smashed together. High frequency, listen to the sound. Right? So for this one, the pitch, that's a very high pitch, right? The pitch of a sound, alright, let's get rid of that, is directly related to the frequency. So how frequent it is related to the pitch, right? So that's A. Cool. Number 8, high-pitched sounds have relatively large blank and small blank. Did I say number 8? Yeah. So high-pitched sounds, let's look at that deal we just looked at again. Well, it's definitely high frequency. High frequency, by default, means short wavelength. So the distance between these waves is really short, right? So high frequency, short wavelength. So that looks like C. Cool. All right, number 9. As frequency of a sound increases, the wavelength blank and the period blank. Let's think about this. Definitely the higher frequency, goes, the wavelength gets shorter, right? So we can be like, nope, nope, right? So now you know it's B or D. So then the question is, what happens to the period when the frequency increases? Let's look back up here and let's get a reminder of period. So period was B. How much time it takes to complete one cycle? Well, doesn't it take less time to complete one cycle when there's a very high frequency? So that means it's D, right? Because if there's more frequency, it takes less time, which means the period, takes less, right? Cool, so that's D. All right, number 10. We're skipping these windows a lot. A sound wave is described as being 384 waves per second. This quantity describes the sound wave's frequency, right? 384 waves a second. Okay, good. So there you go. There's that. Period, by the way, because some people are going to confuse me, like, why isn't it period? Period is in a given time. So it's like how many vibrations in 10 seconds. Frequency is just, how many per second, right? So that's the difference. Period is given time versus frequency is just how many per second. Okay, so that's why that's A. Number 11, the speed of a sound wave depends upon its blank. Okay, so remember, sound travels at the speed of sound, right? So in that case, the speed does not really depend on the wavelength. It doesn't depend on if it's high frequency, low frequency, and it doesn't depend on the amplitude, how high or low, these waves go, right? So it actually just depends on the property, the medium. Air, it travels a certain speed. Solid, usually it travels a little faster because the molecules are closer together. And water, water's kind of the middle. Air's actually kind of the slowest because the molecules are kind of spread out. Whereas the fastest is usually solid. Everybody's like, whoa, I thought it was air because I talk in air. Well, no. All right, number 12. If a person yells as opposed to whispering, then it will cause blank. So the sound wave will travel faster. Well, we just established that's not going to happen. Air molecules vibrate more frequently, or air molecules vibrate with greater amplitude. So in this case, they're just going to vibrate with greater amplitude. Bam. C. Number 13, if a person yells as opposed to whispering, it will cause... This is a funny answer. Pitch of the sound will be higher. The pitch of the sound will be faster. The loudness of the sound will be louder. It's actually C. As silly as that sounds, the loudness of the sound will be louder. If you guys need supplemental help, go to these sites here. If they're not working, because some people have a problem, sometimes it's you enter it in wrong or you don't capitalize the right thing. This is what I usually advise people to do. Just Google, search physics classroom space sound. And it should take you somewhere to one of these, and that'll help you out, okay? So if you can't go to these direct sites, Google physics classroom and then space sound. You should be able to find everything you need. All right, guys, there is page 2.